You know, in our closets, we've all got those perfectly colored sweaters and t-shirts, but we almost never stop to think about how they got that way. Well, today, we're going to pull back the curtain on one of the most important but least known machines in the textile world, the real secret behind your favorite clothes. Let's dive in.
So, think about your favorite sweater for a second. You know, the really soft knitted one. The color is just perfect. It's even all over, the fabric isn't all stretched out, and there are no weird lines or creases. How on earth does a factory pull that off on a massive scale without totally destroying that delicate material? The answer is actually surprisingly elegant.
The secret, well, it's all about solving a really high-stakes problem: how to dye delicate fabrics without ruining them. And believe me, it's a process that is just packed with risk, where one tiny mistake can be an absolute disaster.
And when I say high stakes, I mean it. Knitted fabrics, by their very nature, they want to stretch and distort. If you process them with too much tension, you get these permanent creases that they call rope marks. One bad batch with splotchy, uneven color, that's not just a few lost shirts. We're talking about a potential multi-million-dollar mistake. So, how do textile companies even begin to manage that kind of risk?
Well, you manage it with a very specific and very clever piece of engineering. So let's meet the hero of our story, the Winch dyeing machine. And this right here is the laboratory version of that machine. Now, it's not just for dunking little fabric samples in dye to see if the color looks nice. No, its primary job is way more important. It is designed to be a perfect simulator, a tiny dress rehearsal for what's going to happen on the giant factory floor.
And that's exactly what it is, a full-on dress rehearsal. Before a company commits, literal tons of fabric and thousands of liters of dye to a production run, they run a test here first. This little machine has to prove that not only is the chemical recipe for the color correct, but that the physical process itself won't tear the fabric to shreds.
So how does it manage to be so gentle? Well, its genius lies in one simple but fundamental difference in how it approaches dyeing.
All right, check this out. Most of the dyeing machines out there, things like jet dyers, they work by powerfully blasting and circulating the dye liquid around the fabric. The Winch machine, it flips that script completely. The dye bath, or the liquor as they call it, stays perfectly still. It's the fabric that does all the moving.
You can see it right here in these diagrams. The fabric is sewn together end to end to make this one long, continuous rope. And that rope is gently lifted out of the dye by a rotating reel up top. That's the winch. And then it's just dropped right back in. This cycle just repeats over and over, super slowly and continuously, letting the fabric move through the dye with almost zero stress.
The entire design, the whole thing, is engineered around one single, absolutely crucial principle: achieving the lowest possible tension on that fabric.
And how it does that is pretty fascinating. First off, that reel at the top, it doesn't actually grip or pull the fabric. The movement comes just from the weight of the wet fabric itself and the friction it has against the reel. And to help with that, the reel's surface is often corrugated or textured. But the most counterintuitive part, the real secret sauce, is that last point: using a ton of water.
And that brings us to a really critical number in the world of winch dyeing, the material-to-liquor ratio, or MLR. A pretty typical ratio for one of these machines is 1 to 20.
So what does that mean? It means for every 1 kilogram of fabric you're dyeing, you're using 20 liters of water. Now that might sound really inefficient, but it's actually the key to the whole gentle process. All that water gives the fabric buoyancy. The rope literally floats and drifts through the dye bath. This minimizes friction and stops the fabric from piling up and crushing itself. It creates this perfect, relaxed, low-stress world for the fabric to live in.
So as you can probably see by now, this machine's job goes way beyond just getting the color right. It's really about making sure the final product is physically perfect. This quote just nails it. I mean, you can have the most perfect, beautiful color recipe in the world, but if the dyeing process turns your amazing knitted fabric into a stretched-out, creased-up rag, that recipe is completely worthless. The lab winch validates the entire process, the chemistry and the physics, all rolled into one.
So, what is that #1 physical threat that this machine was designed to prevent? What's the defect that keeps textile engineers up at night?
It's this: rope marks. These are these ugly, permanent, lengthwise creases that are pretty much impossible to get out once they form. They happen when you process delicate fabric in that rope form under too much tension or pressure.
And the Winch machine, with its whole low-tension, high-buoyancy philosophy, is the ultimate defense against this exact problem.
Okay, so let's put all the pieces together and see exactly where this machine fits into the whole research and development workflow, from an idea on a computer to a finished product on the shelf.
So it all starts with a computer program that predicts a dye recipe. Next, that chemical recipe gets tested on tiny little swatches in a different machine called an IR beaker dyer. But then comes the critical third step, the process simulation. This is where our hero, the lab winch machine, steps in. It takes a much bigger sample, an actual rope of fabric, and simulates the entire physical journey, testing both the color and the stress. Only after it passes this test does the process get the green light for bulk production.
And you've got to understand, the difference between these two lab machines is everything. An IR beaker machine is all about chemistry. It takes a tiny swatch, holds it still, and just asks one question: is the color chemistry correct? But the lab winch machine, it's about physics and mechanics. It takes a real rope of fabric, puts it through its paces, and asks the much more important million-dollar question: will this fabric survive production without being ruined?
So the next time you put on that perfectly colored, flawlessly soft sweater, maybe you'll appreciate the hidden engineering that made it all possible. It's really a testament to a gentle giant of the textile world, working behind the scenes, protecting the delicate fabrics that we all love to wear.
And that really gets you thinking, doesn't it? The Winch machine is a perfect example of an unsung hero, a piece of tech that solves a really complex problem so well that we never even notice it's there. It makes you wonder, what other invisible, brilliant bits of engineering are hiding in plain sight all around us?